Hi, this is Sheikh Jahiruddin again. In this video, I will be discussing December 2019 CSIR Net Physical Science Part B questions little bit. I am not going to discuss the solutions explicitly. Rather, I would be discussing what type of questions were there and where from you should read and what minimum concept should you have to answer these questions. Which questions are easy and which questions are tough, I will be also be telling. So the first question, this is very easy question. Harmonic oscillator the system is, and this is a dissipating systems also. The energy is decreasing. So slowly the phase space diagram will collapse into a point. So energy will be decreased. So what will be the options? You can see the harmonic. This is a plain harmonic oscillator. This is harmonic oscillator. This is not a harmonic oscillator actually. The arrow is inverse. So this is a dissipating system. So for dissipating system, slowly the system will get up into zero. So this is not, because the system is diverging. So this cannot diverge. This will converge. So where from you should read these all phase space things. There is not a very particular book on that phase diagram things. You can read very classical mechanics basics textbooks and you have minimum concepts of what a phase diagram is. Then you will be able to solve these kind of questions. There are many problems on phase diagram already asked in the previous year questions. So if you have understood and discussed with your teachers, then this was very easy for you. This is electronics, little bit out of my own syllabus, so I don't know if that exactly will be the question answer. So I will skip that question. This is higher secondary level question. Positively charged particle, zero initial velocity in the presence of constant electric and magnetic field along positive z and x direction. So large time the overall motion of particle will drift along the. You just apply the minimum basic rules of electric and magnetic field. You also don't forget the Lenz's rule, means if Lorentz force law, sorry, not Lenz, Lorentz force law, force equals to Q E plus V cross B, and you will get the option. So that is as simple as that AC Pharma level of plus 2 question. This is again easy question. To spin half fermion in one-dimensional finite potential, particles are known to be in spin triplet state. So what is spin triplet state? Spin triplet state is spin 1. So spin vector 1. So spin vector 1 means this particles have do not share the same ground state. If the particle is spin half plus up and spin minus up in the ground state, the energy will be minimum, but that will be spin singlet state. Spin triplet state is one particle. This total spin s equals to 1. So s equals to 1 means the particle have s z equals to may have plus 1, 0, minus 1, all three. So one particle should be in ground state, another particle should be in fast excited state. So the energy will be the ground state energy plus 4 into the ground state energy. So this varies with n square, you should know. So the last option will be there. So you just know the definition of spin singlet and spin triplet and do your option right in the exam hall. This is not actually a confusing question. This is a very good question. Somebody was getting 0, but this is not 0. Surjit Pal sir has already solved the question and posted in our Facebook group. So you could just see from it, and if you have solved the complex analysis problems, say from Spiegel's complex analysis or Riley-Hobson-Benz complex analysis exercises and problems, or Emil Boas quantum complex variable exercises, then you would have easily done that. This problem is very common question actually. This is very simple. You just calculate electric fields and then the work done is potential difference into Q if the potential difference is constant. Otherwise you just calculate the electric field and calculate the force and integrate, you get it work done. So this is not tough. The plane, you know the electric field from a plane, right? So very simple Griffiths level question. This is probability question and very easy questions also. Just higher secondary level permutation and combination level questions. So that is also you could do very easily. So this type of questions quantum mechanics has already asked in previous problem. So the only trick is you just you see that you are being asked to find L square and Lz. You convert your Cartesian wave function into spherical polar, x square plus y square plus z square, replace it by r square, and this z you replace by r cos theta. So it is some constant into r cos theta into exponential of minus a r square. So this is, you easily identify it is with y10 spherical harmonic with L equals to 1, Lz equals to 0. So then you get your answer very easily. So with L equals to 1 and Lz equals to 0, the option will be 2h square and 0, L into L plus 1. You should not forget the eigenvalue of L square. So once again, these questions have been asked in previous years. If you could have done, if you had done this type of eigenvalue problems in angular momentum previously, then that is easy for you. This is very easy, given the force asked to see it, whether it is conservative or not. You just make it take the curl, make it 0, very fine. This is Lagrangian question. In this question there is a confusion. Where there is a confusion, I will tell you. The perspective of the question is if you add a total time derivative with a Lagrangian, means L plus ddt of f, where f is a function of space and time, total time derivative, so your equation of motion does not change. So the issue is which option can be written as a time derivative of a function of space and time. So at the first glance, the option 2 is total time derivative of a function, and which function it is? It is the option 2 is this x y double dot minus y x double dot is total time derivative of x y dot minus y x dot. So this is total time derivative of a function, but issue is this is acceleration are there. So Lagrangian cannot be a function of acceleration, and when you are taking time derivative of a total of a function, that function which is actually this function, so this is this function itself is a function of velocity, but the theorem is ddt of some function of space and time only, means x, y and t. So that's why I think this option will invalidate the basic formalism of Lagrangian also. So acceleration cannot be there here. So if only function of velocity is this 3 and 4 option remains. But I could not find any function of which the total time taking time derivative you arrive into 3 or 4. If you can find some function taking time derivative of that function, you arrive any of these two functions, then you are fine, you are done. But I still could not get it. Here also some people are saying some confusions are there, but I don't think there is a confusion. Just one point you missed, that nowhere in the question the gas has been asked to be ideal. So if the gas is not ideal, if you are taking time derivative, if you are taking the total change of entropy, you just cannot say CVDT by T and taking integration and getting option 3. That is not done because your volume is constant, but pressure is varies. Pressure will vary. So your temperature is varying and pressure is also varying. So then entropy is not a function of temperature alone for real gases. So the entropy will be a function of pressure also. So on my hint will be the look at the TDS equations. TDS equation, that entropy has been written as a function of both temperature and pressure, and temperature and volume. You take the temperature and pressure equation. Where you get TDS equation? If you have Jimansky, you will have TDS equations. You have got Banchal and Ghosh, you study TDS equation, then you do. The regas is not ideal, so you will get some different option, not option 3. Here you have 3-state system. You need to get the specific heat. The direct way is just calculate the partition function, calculate the energy, then calculate the specific heat and look which option it should match. For 2-state system, the entropy is kind of like this, specific heat is kind of like this. What will be for 3-state system? I have not evaluated it explicitly, but you can do. You have 3-state system, calculate partition function, then calculate specific heat. If you have done that for 2-state system, then you could have done this in the 3-state system. So this is not tough, no different other things. This is a little difficult question, not very difficult also. If you have sound knowledge on vector space, this is dimensions and linear algebra, you can do that, but I don't suppose many of you will have this, so you may skip that. But what should you do to answer this type of question? That you should study vector space. Where from I would study vector space properties? Riley-Hobson-Benz, there is chapter 8, I guess, vector spaces and matrices. There you study vector spaces property first, then you try again. You may get a option, and if you still face problem on vector space, let me know by commenting or message me or email me or post in the Facebook group. We will discuss, we will see what we could do this type of question. So this is a little bit new type of question. This is very easy. Carnot engine taking heat and dumping heat, and temperature is one source, sink is been given, so heat source. That is very easy, free gift. This is 2-dimensional harmonic oscillator. To be able to do this, you should have done 1-dimensional harmonic oscillator partition function at some time in your life. So if you have done 1-dimensional harmonic oscillator partition function, then the 2-dimensional harmonic oscillator partition function should not be very tough. So this is very easy. So 2-dimensional harmonic oscillator, the energy is nx plus ny plus 1 bracket h cut omega outside. So nx plus ny plus 1, then you calculate the partition function, that is summation. So where summation over which part? Nx and ny. And very interestingly, if you just this nx and ny is 2-dimensional harmonic oscillator, the Hamiltonian is separable. So Hamiltonian is separately as 1-dimensional harmonic oscillator plus another 1-dimensional harmonic oscillator. They don't interfere. So you can calculate to just partition function for 1-dimensional harmonic oscillator and just multiply or take square. That is the most simple thing. You should not have done that summations explicitly. You just calculate 1-dimensional harmonic oscillator partition function and just take square of it. That will be the 2-dimensional harmonic oscillator partition function. In some questions you need to think little bit, right? You need to try. So for 2 different systems, Z equals to Z1 into Z2, and where this 2 system is different, Hamiltonian is separable. H is H1 plus H2. So Z will be Z1 into Z2. The 2-dimensional harmonic oscillator is summation. This is just 2 separate 1-dimensional harmonic oscillator which are mutually not interfering. So then you could have done this. Well, this is also very easy. You have an electric field. Then what you will do? This is an electromagnetic wave. So B equals to K cap C, K cap by C, cross product of E. So the average flow of energy, Poynting vector, you calculate. You have B, you calculate B, you calculate Poynting vector. Done. Flow of energy. 2-line, 3-line calculation, 2 minutes calculation. Here the trick is, in quantum mechanics problem, if you are given a wave function which is not exactly the summation over the energy eigenfunction and asked the expectation value of energy, you will need to write the wave function in terms of the energy eigenvectors. So what are the energy eigenvectors for one dimensional box? Energy eigenvector is root over of 2 by a sin n pi x by a sin n pi x by a. So that 2 by a sin n pi x by a, so that you need to write this function in terms of the summation of the sine function. First term is fine, this is sin pi x, the ground state wave function. For the second term, you need to apply the sin pi x into cos pi x. Just you break it up in using the formula sin a cos b. Sin a cos b you break, you will get what you should have got. So then you could easily do this. Where these type of questions are discussed in Griffiths, the example you will see. If you read thoroughly David Griffiths' book or Jet Li's books, you will see that in one-dimensional harmonic oscillator, after one-dimensional potential box, these type of questions in Griffiths has been discussed, that some arbitrary function, and then he has to explicitly express it in terms of energy eigenfunction, then calculate energy eigenvalue. This particular problem, I guess, taken from Y.K. Lim's quantum mechanics first chapter. So a rigorous study is required, right? You just cannot have a sample suggestion type of question study. If you are reading quantum mechanics, you read Griffiths, explicitly solve the examples, understand it, and do the exercise also. Then your study is being completed. You just cannot have a 5 pages note of quantum mechanics, 10 solved problem list, and all problem will be done. That won't happen any day. A little bit rigorousness is necessary, right? This is out of my knowledge for the time being. So this I will see how this can be done. If you people has already done that or somehow got the concept right, you just please let me know by emailing or messaging me. So this I am also very curious to solve this. This is also higher secondary level of dropping ball problem. Coefficient of restitution is, you know the definition, then you easily do. Any class plus 2 level of joint entrance preparing people will be able to do that. This type of question has been asked previously also, but you may not be able to do it in the exam hall. Whenever I will give you a suggestion, whenever you will see this S1.S2 or L1.L2 or some dot product from some two angular momentum vectors, you should, what the question should come to your mind is the addition of angular momentum concept. So that is not Clebes-Gordon I am saying. You have S1.S2, you just add these two vector, define S is S1 plus S2, then you take SS square. SS square is S1 square plus S2 square plus 2 S1.S2. So S1.S2 equals to SS square, S is the addition, SS square minus S1 square minus S2 square by 2. And this S square will be eventually S into S plus 1, S1 square will be S1 into S1 plus 1, S2 will be S1 S2 into S1 plus S2. Then you just where do you see the question, largest eigenvalue of the Hamiltonian. So you have the spin vector, your one vector is 1 and the other vector is half. You got explicitly the expression and you just try, you just put 1 and half. You just see for which value the largest eigenvalues come. Means S1x, S2x, the values will be 1, 0, minus 1 for S, and S2 will be half and minus half. Then you just check the overall, the eigenfunction will be largest for which set of combination, then get the result. Only thing is S1.S2 you use S square minus S1 square minus S2 square by 2. The same thing you have done in addition of angular momentum, same thing you have done in the Zeeman effect. And the exact similar type of question has been asked in previous CSIR questions also. That's why I always tell you to solve the previous year questions and get the concept right. Then your 70% work is done. Hey guys, this is black body radiation in thermal equivalent 2D box. If it is 3D box, then it is TQ. It is 2D box, it is T square. You should have explicitly done this 2-dimensional calculation or 1-dimensional calculation or D-dimensional calculation. I always tell people that do the D-dimensional calculation. If you do D-dimensional calculation for this all the statistical mechanics problem, then your 1D, 2D, 3D, 4D, everything is done. You need to do this. This is again electronics, and this is easy. This looks easy for me also. So I just do a simple op-amp concept and you will get. And this is electrodynamics, and this is not very tough. Why not very tough? There is a some current conducting wire loop. This is your solenoid, so magnetic field inside the solenoid will be along the axis. So the magnetic field will pass along the axis, this direction. If you change the current, so the magnetic field also change. You change current very sharply, magnetic field will change sharply. Change current slowly, magnetic field will change slowly. And what will happen? This loop will induce current. Why? Changing magnetic field means changing magnetic flux inside the loop will generates an electric field along the loop. You have read Griffiths in electrodynamics? Of course you should have. Changing magnetic field creates electric field, changing electric field creates magnetic field. So the magnetic field changes here, then the current will be induced here. Magnitude of the induced current of course will be proportional to rate of change. So the problem is explicitly solved in Griffiths. E dot 2 pi r equals to the total flux. This is the EMF. This is the rate of change of flux, dB dt into pi r square. So E is dB dt into pi r. dB dt into r by 2. dB dt into, because 2 pi r is left side, pi r square is right side. So the induced electric field will be proportional to the rate of change of the magnetic field, and rate of change of the magnetic field will be proportional to the change of I. So the issue is how quickly the current changes. The induced electric field will be stronger if dB dt is high. dB dt is low means the rate of induced magnetic field is low, means rate of change of magnetic field is lower in this portion. So the induced electric field will be also means weaker in this part. So the higher magnitude current is there, lower magnitude induced current is there. Of course the width is little bit long because the rate of change occurs in longer time frame. So this breadth will be higher here. This will exist in shorter time frame, but the magnitude will get picked up as the rate will be high. Not exactly asked in previous years, of course, but you have little bit thinking process and know the basic concept. This is done for you. Error calculation question is the easiest question asked. Del V by V is most easily del K by K plus 2 delta X by X. Delta X by X is 1%, so 2 into delta X by X is 1%. Delta K by K is 0.5%, so delta V by V is equals to delta K by K. Delta K by K give you 0.5%, and then 2 into delta X by X will give you 2%. 1% error is there, so you will get 2.5 answer. If you've done it rigorously, not using that formula, the proper theory of propagation of error, then also you get little bit greater than, I have explicitly done that calculation, greater than 2 your answer, and easiest and nearest answer will be the 2.5. So 2.5 comes in anyways. Rank of n cross n matrix is m. So what will be the rank of A square? Rank will not increase, right? Say if you have 2 cross 2 matrix and the 2 cross you are given rank is suppose 2, you square your 2 cross 2 matrix, the matrix will remain a 2 cross 2 matrix. And if matrix remains 2 cross 2 matrix, the rank cannot go to 4, right? So first your increasing option get reduced. Then should the rank decrease? Why should the rank decrease at all? You have rank 2, you are squaring a matrix. Squaring is not doing any row operation or column operation. Square means just square. Multiply the rows with their columns, multiply these rows with their column part. So the linear dependency or independency factor of that matrix element does not change at all. So the square rank should not decrease the rank. Rank, what does the rank mean? Rank is the property to have linear dependency or independency of that vectors. So you formed a matrix with 2 vector to the component of the vectors. So the squaring means the linear dependency independence factor does not change. So the matrix element will be, the rank will be again the M. Rank will not change. So I think we have finished this part B. I will be again coming back for part C questions, but today we will bid goodbye to you. We will be again coming back for part C questions after 1-2 days. And finally, what I should like to say you that the questions were not very tough. Every paper there will be 20-30% or 40% questions which were not asked before. So, but with the questions which were asked before, you should have answered. Of course, you be jack of all trade. You know simple things. You just do it easily. This B part was very easy. You are been asked to answer how many questions? I think 25 questions were there here. So 20 questions you are being asked to solve. 20 questions, 15 questions at least were easily done. So my request will be to subscribe my channel, and so if you subscribe, I think you will get notification when I will again upload part C. I am not very good YouTuber, but still I started learning this YouTubing and screen recording. I think I will improve more. So please be prepared for the next part. Thank you very much.